few words about the USB CAN converter device. Looks like on the picture there is USB, micro USB connector terminal block with CAN low, CAN high, and GND pins, and also a jumper for terminal resistor. Device use CAN FD up to 8 megabits. Transceiver is microchip MCP. Device is recognized as virtual COM port after the connection, so you do not need any additional drivers. It works under both Linux, Windows. Together with the device, there is an application that is written in Python that is used for displaying what is on the CAN network, and you can also send the CAN frames with it. Application after the download, you need to extract the zip archive, and then you have a configuration file in which you can choose on which COM port the device is recognized. Normally on Windows this is as a COM port, yes. So you can see at the device manager as a real device COM port. And next we need to define the arbitration phase baud rate of the CAN interface, because FD-CAN has two different speeds for data and for arbitrage phase. So you can set it up. There are also a set of additional options. So all the options that you can choose from are on the web page. Let's go back to the application. We can start it after the configuration of the CAN, and it looks like this. Let us click connect, and then we can send the data on the network. Here we are defining what data we want to send, ID, flags, bitrate switch, extended flag, and so on. And after clicking set, the device is sending the frames. I have two devices in the networks. One device is sending a frame ID 0, data 0. Flags are displayed to the right side. Other options are we can refresh the device. So after clicking this button, the device will go to the bootloader, and then we can upload new embedded software via USB using the S42 device programmer. This is all about the application. Device has also its port to Python CAN library, so you can use the Python CAN with this device. Currently, it is not integrated, it is not merged into the master, so you need to use my fork from my repository, but hopefully it will be integrated into master soon. What we can do with Python CAN, you can send all and receive the CAN frames and use all the features of the Python CAN. There are some examples on the repository. If you go to the tools, examples, you can see some examples on how to receive the frames. So you need to create new variable bus. Here you initialize the CAN bus, and then with the bus receive, you are receiving new frames, and you can display it. This example is actually just displaying the frames. The next example is how to transmit the CAN frames. You can also, with additional libraries, for example, ISOTP, receive and send segmented CAN frames, so longer than 64 bytes or 8 bytes in the classical CAN case. So it's fairly easy to use it. With PB, you need to get the library, and then you can use it as here. Same with UDS and CAN. You can use it with this device and test the UDS using this device with RDBIs and WDIs. Device and embedded software is open source. It's hosted on GitHub from Microcan device. You can get all the links.